Hi, today we're gonna do binary search. It's an easy problem, and I was supposed to do the stack, but like that's the next problem to my the stack roadmap. That shit is hard as fuck, bro. I'm not doing that shit. I mean, I was doing it, but that shit was confusing. So I'm gonna like skip it. So I'm gonna do this. So first, binary search. I think I kind of remember it from my class. Basically, there's like a left and a right pointer. So L is gonna equal 0 and R is gonna equal the length of nums minus 1. So you get the index, the last index, you know. And while our pointers are valid, we gotta do a less than or equal to because I mean less than and equal to because when they cross, I shit, I don't know how to explain that, but we just need that. Okay, we just need that. Then to get the middle, the formula is like I think like this. Shit, I'm gonna just L equal R minus L. I think it's like this. Hold up. R minus L divided by 2. I think it's like that. I think it's like that. You know, the parentheses. Okay, maybe like that. Then we check if the value at our middle index, if it's less than the target, then we want to move our pointer, our left pointer, to where the M currently is. So if it's like on the left side, we want to start with M, then we want to add 1 because we already checked the M position. Then else if none of that at our middle, if it's greater than, then we do the opposite. So we want to uh, change our pointer, our right pointer to M. Like if it's in the middle, then to the like, one more, one more, one more index. That way, that's how it like it. That's how it like cuts the problem in half. So you keep searching each time is like half half. Then else we can just return M. Then once we go through this loop, uh, that means we couldn't find our target, so we just return -1. Yeah.